Thanks for your patience. I was asked to give an overview of some of the challenges with respect to materials resources. As Brajendra presented at the beginning, there are different sectors that we're looking at. Mine will be more focused on and centric to materials. However, if you think about it, materials are pervasive, and all the things that we do and all the things that we need do require materials. If one thinks about it from a very simplistic perspective as to what the needs of the 21st century are going to be, there are many. For example, if you see that list that's on the screen, we don't have cybersecurity there, we don't have a lot of other issues, but I look at these six pillars or six axes as almost Maslow's hierarchy of needs. We do need energy, we do need food and water, housing, shelter, mobility, which obviously includes IT, aerospace, transportation, roads, etc. And needless to say, health. The one that I'll be focusing on is on the materials. But I think these six areas are an incredible set of challenges for the 21st century. And in fact, I've actually used this slide as a way of recruiting students into engineering and specifically into materials engineering. I think the three key pillars or three key axes with respect to these six areas has a foundation in education. We need to educate and make sure that we understand the context and the issues that we're facing. And needless to say, policies. If you look at the 6 bullets that Professor Mishra presented, the last two, social and policy, very much fall under that policy one. And innovation technology is what we do, but we cannot be blind that the need of policy is really critical. In fact, at the end of this presentation, I will be spending quite a bit of time on the policy area and some thoughts for the future as we go forward. It's a nascent area, really. It's a nascent area because most countries think about it from their own perspective. And yet, the issues that we're facing requires a holistic, global perspective. Now, those are all nice words, but to be specific and give you an example, rather than be abstract and ephemeral, let me give you a scenario. You're driving down on the Florida Turnpike here, beautiful roads, greenery everywhere, no snow, lots of sun. It's a beautiful day. And there's a car in front of you, which is a van, and people are throwing things out of the window. Bags, McDonald's, trash, whatever. And you say to yourself, what in the world are they doing? What are they thinking about? How could they do this? Yet the people in that van are cleaning their car. That's what actually we're doing with a lot of our electronic scrap today. We're cleaning our country. We send it to other parts of the world where these things are melted, lots of toxicity, environmental degradation. So one cannot think about these issues that I'll be speaking and trying to have a dialogue with you a bit later on in a country-centric perspective. It's got to be a more global perspective. And when it comes to corporations, global corporations, their challenges are even more complex because you have political issues, political forces. Just imagine dealing with the US Congress versus the whole world. So thankfully, the Schwab Foundation is doing something about this, where they're trying to instigate at the World Economic Forum a group where they can think about policies that are not national-centric or one-country-centric, but holistic. So these are the 3 pillars, or in addition to the 6 pillars, these are the 3 areas, axes that one has to think about. So in this plenary, I thought I'd give a little bit of societal context. Some of you have seen these before in some of the presentations, the challenges, the strategies, but I will focus quite a bit on the circular economy and the path forward. This audience certainly knows the population growth, but I'd like to just focus on two numbers. That we entered the 20th century with 1.6 billion and we exited with 6.1 billion. Tremendous growth, and we're looking at over 9 billion in another 20, 30 years. It's an interesting period in our history of our civilization. If you look at over a long span of our planet, the history of our civilization, you don't see that in a period of 20 years, which is nothing when you compare it to 5,000, 10,000 years, in a period of 20 years, that the standard of life increased dramatically, about 35% of the world. This is a profound change, which is a good thing. Whenever you increase standard of life, that's a good thing. But it has consequences that cannot be ignored, and more importantly, for us to go forward, these have to be tended to because it is certainly not sustainable. Just look at metal production. Metal production, what you're looking at the ordinate there is the annual production of a variety of elements over a period of time. The dimensions are, needless to say, different. Diamonds are in carats and iron ores and millitons, but nevertheless, what you see is a tremendous increase in the production of these elements. And more importantly, if you look at the last 5 years, between 2000 and 2005 and 2010, that is really going up exponentially. It certainly fits in with the previous comment on the increase of our quality of life. So as production of metal is increasing, at the same time, as I'm sure you'll hear from our SME colleague, the grade of the ores, that is the quality ores, or think of it as how much stuff you got to take out of the ground so you can get the material, the elements, is going down. So whenever you have these trends, one going up, the other one going down, it's certainly not, it is a recipe for disaster if you don't do something about it. So this is not an issue where is debatable. The facts speak for themselves. At the same time, we're using more and more of the Earth's elements for things that we use. In the older days, it was more structural integrity. Today, in addition to structural integrity, we want functionality. So we're using elements of the periodic table that have specific electronic characteristics, such as the lanthanides and others. And as you can see from Intel, that in a period of 20, 30 years, the computer chip has become much more sophisticated and over 45 elements today. This is not a smartphone. This is actually an older Nokia-type cell phone. And I borrowed these from Christina Meskers from Umicore. And it's a very conservative calculation. There are over 7 billion cell phones today in use. But if you look at just the cell phones or the PCs, there's an abundant amount of elements like gold, palladium, copper, and cobalt that if they're not reused, if they're not recovered, I should say, and then reused, it's a tremendous waste, a waste that we cannot afford. The UNEP study clearly pointed out the opportunity or the challenge or the situation that is not acceptable, that if you look at the periodic table and you look at the end-of-life recycling rates, you're looking at rates that are dismal, and we don't really have, it's not a good story, and there's a challenge for us to attend to. Now let's look at cost of things. If you look at commodity prices, they have increased sharply since 2000. erasing all the declines of the 20th century, and you've got a few milestones there, World War I, World War II, the 1970s oil shock. But look at what has happened between 2000 and 2011, most recent data from McKinsey, actually. And then if you look at annual price volatility, which is even more difficult to deal with, especially if you're a corporation, a global corporation, you need some certainty for planning, et cetera. If you look at energy, food, metals, quite a bit of volatility in prices. And then if you look at resource extraction, that is projected to grow to 82 billion tons in 2020. And that number was 65 in 2010, just a few years back. Compounded annual growth rate, the CAGR, is about 1.8%, but you can see the percent changes between 1980 and 2020. I think I made the point that, hopefully, that consumption, quality of life increasing, standard of life increasing on many parts of the world, in developing countries, and it's actually going to grow even more in Africa with all the projections. We have a real issue with these that cannot be ignored. So if you look at today in terms of the challenges, you look at the T5 fluorescent lamps. The target date for the transition to the high output lamps has been delayed for 2 years because there was a shortage of the europium and terbium for the phosphors. If you're in the wind turbine business and you depend on neodymium and dysprosium, they've also seen the effect of volatility. If you look at the prices compared to gold and silver, you'll see that the neodymium and dysprosium, perturbation certainly, but due to geopolitical forces or scenarios that occurred a few years back, the prices of neodymium and dysprosium and the rare earth elements spiked incredibly. Just in a tabular form, it's easier to read, I think. In a period of January 5, 2010 to August 5, 2010, which is only 6 months, you see the increase of lanthanum and samarium by crazy numbers like 500% to 700%, and cerium also. Those prices have come down now. They're not at those, but it can happen again. So there are really two pathways. How do you do this? One, you produce more. You use less. So one really has to address the materials life cycle from cradle to cradle, but also look at how we can mandate a behavior, Pavlovian actually, a behavior that is different than what we're doing now. So there are the 4 R's there: redesign things differently, reduce things different than the way we're doing it now, recover them, reuse them. All these R's requires a transformation of behavior, a transformation of mindset, and a transformation of our meta beliefs as to how we view the world and how we address it. Waste is, I wanted to put the waste in the storyline here because it is the product of the behavior if we do not do the things such as redesign, reduce, recover, reuse. The consequence is waste. And if you look at end-of-life recycling rates, you can see there from natural resources to production to fabrication, use of products, end-of-life products, and some of it is discarded as waste and downcycling, some of it is recycling. So the end-of-life rates are very, very low. Recycling aluminum cans is, especially when I speak with some of the first-year students at the university, because when they see all the bins for recycling, they think that the recycling rate is very high. And yet, if you look at a few countries, USA is in blue, the recycling rate of beverage cans is less than 52%. A lot of it does not get recycled. Whereas in some other countries, like Japan and Brazil, very high recycling rates. So what is it different about the North America and the South America? It's got nothing to do with technology. It's got to do with policies and human behavior. I think electronic waste, I'm going to skip this. A lot of things are ending up in landfills. And the landfills are actually becoming our urban mines of the 21st century. To get 1 ton of gold ore, from 1 ton of gold ore, you get about 35 grams of gold, whereas 1 ton of used cell phones, one can get 200 to 300 grams of gold. So there is an opportunity to recover and reuse these materials from many of our end-of-life consumer wastes. What I'd like to do is put one slide on and tell the story about how we can learn from nature. On the right, you'll see the industrial system. On the left, a natural ecosystem, which, as you well know, has been around for a long time, has served humanity well, and it's been here for a while. If you look before the Industrial Revolution, before 1700s, 1800s, we didn't have some of the situations that we're facing now. But today, the industrial system as a whole is an open loop system in contrast to the closed loop system in nature. In nature, we have a lot of subsystems. If you just even look at the watersheds and the earth and how it all functions together. In industrial system, we don't have subsystems. It's a linear system, open loop versus cyclic and closed loop. And we use, as you saw already, a lot of elements of the periodic table. Indicator of well-being in nature is really equilibrium. And yet the indicator of well-being in industrial systems is growth. And not that I'm against industrial systems, I'm very much for it, but there are lots of lessons we can learn from the column on the left and bring them into our industrial system so that sustainability is sustained, if you will, and that we're addressing these challenges and issues for society. So closed loop, lack of waste, reduction of waste, or not producing any waste is the way to go. So this cradle-to-cradle approach, as I said, it's more psychological, more human behavior related, which cannot happen by itself. It has to be catalyzed, ignited by policies and a new way of thinking. So we need to go from a linear economy to the circular economy, which has been promulgated by the Ellen MacArthur Foundation, and it's a really good way to look at the world, and it requires different sets of business models. It doesn't happen by itself. So what are some of these strategies? Well, one of it is, as I said, you do the 4 R's, and then the other one is to take waste and make it valuable. Take the waste and do something with it. Third one is manufacturing for disassembly. Make things such that at the end of life it can be easily disassembled and recovered and reused. If you think about some of the products that you use yourself today, many of them cannot be disassembled, let alone being repaired. In fact, oftentimes when things are not functioning properly, the manufacturer will tell you, it's not worth fixing it, just we'll send you a new one. And if you ask the next question as to what happens to the one that I've just finished with, you may not get a good answer. So the responsibility of who owns what really leads to the next issues on the path forward of a different business model of how we own and use products. So those are some strategies. We could spend a lot of time going into each one of those, but I'm going to go quickly through them so I can spend some more time on the circular economy model. I would recommend this textbook called The Upcycle by William McDonough and Michael Baumgart. They're actually the authors of Cradle to Cradle. It's a recent book, but it's all about how to take scrap and make waste a product. In other words, reuse. Interestingly enough, or ironically, at a time when the Earth didn't have as many people, and at a time when the Earth had a lot of resources, and I'm talking about our great-grandparents, they didn't throw anything away. They reused everything. Waste was not something that was in their DNA. If it was, we would never have any sausage. So if you look at, in a village in Germany, for example, how the butcher functions versus how it's done here or in other parts of the world, it's so different. So this idea of taking, I use the metaphor for food, but how to take scrap and make waste into a product and reuse is the way to go. We're doing quite a bit of work in the metals industry by using high-speed computers, by using sensor technologies to go from analog properties to direct property measurements, so that we can take products at the end of life, recover them, and reuse them. There are a whole bunch of techniques that can be used to upgrade scrap. Again, this is not the topic of this session, but you can see that there's a lot of wonderful and neat technologies that are innovations, particularly at the very far right corner. Optoelectronic sortation, laser-induced spectroscopy, and X-ray fluorescence are today being used in greenfield operations to sort aluminum, titanium, and other high-value materials into various alloys so that there is value in the scrap. It's not a mixed scrap. It's not diluted. We don't know what's in it. Indeed, we do know what's in each bin. Then we just remelt it. Using libs, we can tweak the composition and essentially recast things from scrap. So taking scrap that doesn't have any value, put value into it by knowing what's in it, identifying it, remelting, and reusing it. Mini mills of steel have been done this way for a few years, and now we're doing it for aluminum, still in nascent stages, but it has a lot of promise. Manufacture for disassembly is, I think I already addressed it in a few words, but designing products and making them with the end of life in mind is the way to go. If you look at a modern car, and that's not the best drawing of a car, but the best we can do right now, look at some of the products that you have there. These are very difficult products to sort from each other. And in fact, the word that's been used is that these are hybrid monsters because it's very difficult to disassemble. And yet, if this car was designed in a different way, knowing that at the end of life it has to be taken apart and reused, it most likely will be put together very differently. A good example would be your computer, your smartphones, etc. In our Center for Resource Recovery Recycling that Brajendra Mishra and I and Bart Bonpen are directors of, 3 universities working together, we look at our research portfolio and we try to disseminate this concept, this mindset, I should say, not concept, mindset, in this way, where we want to look at production waste, process waste, how we can reduce that, the post-consumer waste, the techniques that we need to develop for being able to do that, the enabling technologies, and how do you do redesign for disassembly. So going forward, I'm going to bring this up again because the policy is the key here. All of them are. They're all important. There are 3 legs to the stool. But the policy is the one where we are the least advanced in today. In some countries, like Norway, like Germany, and others, Finland, they have really taken this at heart, and they have set policies at the governmental level, at both local as well as federal, to ensure that the vision is executed, understanding that it is human behavior that has to be changed. One example, if you look at Tesla, the country where they sell the most Teslas is Norway. More Teslas are sold in Norway than any other. It's the number one import. In Norway, if you have a Tesla, you can park anywhere. You don't have to pay. In Norway, if you have a Tesla, you can go through the tolls on the turnpike and you don't pay. Now, talk about a motivation. I don't know how Elon Musk did that, but he must have done something to get it across. But these are the kinds of policy that changes behavior. In Oslo, if you have a car that's more than 2 liters in size, you pay a lot more money in taxes. And more importantly, if you have a car that's a 3 or 4 or 5 liter in your neighborhood, you're viewed poorly by your neighbors. So it's that kind of these are not easy things to do. These are cultural changes. And in my family, yogurt is very important. In yogurt, you can't make it. You gotta have the culture in it. You gotta keep it warm. You gotta make sure it all works. So cultural changes do not happen by itself. You gotta nurture it, and policy is really important. So let's look at the circular economy. It has a lot of stuff on this slide, but what do you see here? At the very top, you see mining, materials, manufacturing, and if I just go down the vertical column, parts manufacturer, product manufacturer, service provider, and then you have a collection systems, energy recovery, landfills. On the far left, it's more biological, more extraction of biochemical feedstock, etc., whereas on the right, it's more on the services related. But a circular economy means that it's a closed loop system, it's not linear, there are subsystems in between, and you're reducing waste. So if you look at the product manufacturer and parts manufacturer, some of the things that have to occur from a policy point of view is that circular production, design, and production needs to look at material choices optimized for recovery. So think about it. Do we make products today thinking about recovery at the very beginning? Do we really need all of the various alloys, even though I have designed and have patents on various alloys, and I'm just as guilty as everyone else, but there's a time where one has to look at the mirror and see what we're doing. Do we really need 328 alloys of aluminum to make our aluminum products when they can probably be classified into 8 different areas, from aerospace, cars, beverage cans, etc.? We're not designing things to last. We're making things for the consumer wanting to buy something new every 2-3 years. That's a very, very different business model. I'm actually afraid to even ask the question, how many of you use a fountain pen? Probably none, or maybe a few. But in the old days, people had fountain pens. They had it for life. All they had to do is buy the ink. Modularization, standardization. Just think about how many devices you have and how many charges you've got. And I think I made the point about manufacturing for disassembly. So ask yourself the question, how is this going to happen? By me talking about it? By others talking about it? No, it's going to occur by a bunch of companies as well as the government addressing these issues. So there's lots of room here for engineers, for us to be advocates, for us to get the word out and work with the policymakers. It's not going to happen by the lawyers working with themselves, by themselves. It's going to happen by a lot of communication and dialogue. If you look at the other end, the collection side, we need new business models. And in fact, there's a lot of discussion and some work in this area where you're not going to be buying things, you're not going to be buying products, you're going to be buying performance, and you're going to be buying services. You may ask yourself, what's he talking about? Let's take a car. today, the way the automobile industry works is that you buy a car, and they hope that you're going to buy another one every 3 or 4 years. But think about the model where the auto manufacturer, the OEM, has complete responsibility of producing that car, making that car, and recovering the end products at the end of life and reusing it. So now you're on a fee-based service. You don't own the car. You have a contract, just like you do with your cell phone for service. You have a service with whoever's the OEM, the provider, GM, Audi, whoever. And every 4 months you get a new one. In the summers, if you leave in Boston, you'll get a convertible. And in the winters, you'll have an SUV, whatever. It's a different business model. There won't be any dealers. And the servicing will be done. And how the car will be disassembled and recovered and reused will be done by the person who's manufacturing it. So you put the burden, the responsibility on the person who's making it to ensure that it goes back and gets reused. So this is a different way of thinking. Need regenerative systems, collection systems. That's one of the most critical issues in recycling today, to have user-friendly and cost-effective collection systems. But if the manufacturer is the one to whom you return things, that certainly helps. So I think you see that it's not just innovation, that there's a lot of policy enablers that we need for a circular economy. And 3 areas: cross-sector collaboration, a favorable investment climate, and policies to attain scale. And this goes all the way down to regulations in accounting, taxation, certification, standardization, et cetera. So there's lots of work to be done. We're optimistic. And by talking about it, by enlightening each other and elevating the consciousness of ourselves and our mindsets change, I'm positive that we'll be able to do it. Our multi-university NSF collaborative, the very first center in the USA that's addressing these issues. Presenter mentioned in his introduction that he's moving to WPI. Corby Anderson, Professor Anderson, will be taking over the directorship at CSM. And actually, Presenter will be my successor in a year or so. And I'll be doing some other things, hopefully on the policy side on the Hill and other places. So our center is addressing these issues. We're working on it. And the journal that he mentioned where some of these papers will be published is this one, which is a baby of the center, the Journal of Sustainable Metallurgy. So get the word out. And I want to thank you for your patience at the beginning with the mishap with the IT. And if I should add another language in there, let me know after the talk. Thank you very much.